Hi everyone, I am Priyavashni, Assistant Professor, Department of Computer Science from Dr. SNS Rajalakshmi College of Arts and Science. So today we are going to discuss about the bit fields in C programming. So I will explain the bit fields, what they are, syntax and how they compile, stores them, ranges like etc. Okay. So first is what is bit field. So bitfield is equal to a struct member where you specify how many bits that member should use using the colon operators. So use cases store many small values, flags, tiny counters, protocol fields, hardware registered bits without wasting full int or character space. So example declarations, we use a struct as a keyword, as is a name, structure name unsigned int a colon 1, that is in 1 bit. Unsigned int b is 3 means it's a 3 bits, right? So the syntax in syntax and then basic rules is from type name colon with, where with is a non-negative integer constant, allowed base type portable or common, right? So int, signed int, unsigned int, some compiler accepts short or long, but that is implementation defined. Okay, you can have unnamed bit fields. Unsigned int colon 0 means 0 with, forces alignment to next allocation unit, right? So unsigned int is colon 3 means unnamed 3 bit fields act as a padding. So with 0 is a special, with range with a larger than base type bit is implementation defined or non portable. Third is an range of values. Here an example program, right? So ash include stdio.h, studio.h, struct status unsigned int power is 1, unsigned int mode is 2, unsigned int error is 1. Then we go to the main function. Struct keyword we use as a struct keyword, and the status is a variable name 1 2 comma 0. Print statement we use the power, mode and error. If the power, s dot power, mode s dot mode, printf s dot error. Okay, so logical bit is equal to 4 bit total, right? 1 plus 2 plus 1 is in 4 bits we used. So size of s often prints 4. On many compilers unsigned integer is a 4 bytes and compiler aligns struct to 4 bytes, or 1 on some compilers that back into 1 byte. So check on your compiler. Okay, then how range of values is exact math. Okay, for unsigned with n bits, valid values 0 to 2 to the power of n minus 1. So example, when n is equal to 3, that is what means 0 to 7 it takes. So for signed bit fields, implementation defined, but most compilers uses 2's complement. Okay, so semantics and store signed bit in MSB of the field. Typical range, if 2's complement and with n is greater than 1, okay, then minus of 2 power n minus 1, etc. 2 power n minus 1 minus 1. Example, sign 3 bit is minus 4 to plus 3. If compiler treat it is a 2 complement sign, if you assign out of range values, the bits are truncated to fit, that is high bit lost. Okay, for signed field, behavior can be implementation defined, always calculated range using 2 to the power of n arithmetic exact. Okay, then fourth is in how bit field or packed in memory. It is an important. Okay, so the C standard does not fully specify ordering, alignment or packing rules for bit fields. These are implementation defined. So bit ordering inside a storage unit may be LSB first or MSB first, depends on the compiler. Okay, the unit used to store bit field is usually the declared type is unsigned integer. Typically example is 32-bit chunk on many platforms, but compiler can choose differently. The compiler may insert padding between bit fields or at the end of the structure for alignment. In practical rule, don't rely on exact layout unless you target a specific compiler. Architectures and confirm with size of untest. We use the size of function struct to unprint hexadecimal representation of the struct memory bytes. Next, 0 with and unnamed bit fields. Unsigned int 0 forces the next bit field is to start at the next allocation unit boundary. Often the next unsigned int, okay, useful to align fields to new storage unit. That is an unsigned int is 3, that is no name. Act as a padding of 3 bits, okay. Example is unsigned int a is 3 means unsigned int 0 forces next to new storage unit. Unsigned int b is 5 is the next storage unit, okay. The signed versus unsigned bit fields means recommendation prefer unsigned for bit fields unless you explicitly want negative value, means the unsigned, okay. Signed behavior can be surprising and completely depend. Example pitfall. So signed int x is 3 x, we call then x s dot x equal to 5. 5 is an outside signed 3-bit range. That means -4 to 3, right? Implementation define outcome. So safe, use unsigned and do explicit casting when interpreting bits as assigned. So portability use issues what to watch out of this from ordering. First is, okay, which bit is stored where LSB first or MSB first, depends on the compiler or the CPU. Sign as defaults is an int bit field, may be signed or unsigned by default. Prefer signed and unsigned explicitly. Atomicity means bit fields that cross byte word boundaries may not be atomic. Concurrent access require care. Alignment or size of differences is a vary by compiler. Always test with size of. Cannot take address. You can't use $s dot field to get pointer to a bit field member, right? Not allowed types. Float pointers cannot be bit fields. Only integral types is allowed. In debugging, debuggers sometimes show misleading values due to packing or sign extension. When to prefer bitfield versus mask and shift, bitfield are greatly for readability and quick struct-like access when you control the compiler. Mask shift is a manual bit manipulation or preferred for portable cross-compiler architecture code. When you need a deterministic layout on a disk or network, example mask approach, okay. Okay, then so member representations. Members are packed into bytes in orders, cannot access individual bit directly. That is done through the structure, okay. Compact and efficient for embedded programming. Image idea. Image idea bit layer diagram showing a bit fields packed together. Next is what is the advantages and limitations. Is advantages save memory, improve performance and simplifies the hardware programming. In limitations, machine dependent implementations. So no address, we can't use address operator allowed, not portable across compilers. The bit field in C definition allocates a specific number of bits for structure members. The syntax is defined inside structures using the colon operators. Memory representations members are packed into bytes. In DT reflection, we use the empathize, define, ideate, prototype, and test. In application, embedded system status flags, bitwise operators. Advantages and limitations saves memory but has a machine dependent. So there isn't checking actual memory bytes. You can mem CPY the struct into unit. and print byte into hex, that means hexadecimal, to see actual layout. This helps teach students how packing looks on their computer. The warning using unions like above to map to hardware registers bytes is common, but layout and endiness still matters. Prefer volatile for volatile registers. In performance consideration, accessing a bit field may compile to read, modify, write, and sequence. For tight time critical code, measure performance. So compiler often produce efficient code, but mask shift can sometimes be faster or more predictable on some architectures. Okay, in debugging tips and best practices, we go always specify signed or unsigned. Use size of function in code or test a document actual struct size. For portable network file layout, do not rely on bit field packing. Use manual mask. When teaching, run the same sample on GCC and MSVC or target compiler and show differences. Use static assert to check size of compile time when you must ensure the size. Summary checklist founds understand the type name with syntax, compute ranges exactly unsigned, 0 to the power of n minus 1. Prefer unsigned unless negative needed. Check size of struct on your computer. Use colon 0 and unnamed fields or alignment padding when needed. When needed only. Use mark shift for portable wire file formats. Use volatile plus proper access for memory mapped registers. So next, so small program and declare struct bit fields like status print members. Thank you.